Hi guys, welcome to Hagra Maths. This video is specifically for students who are taking the higher paper, and today I'm going to go through some AQA GCSE exam questions on circle theorems. So please make sure that as I'm going through the questions, when I start the question off, I'm going to remind everyone as well to just pause the video, try and have a go at the question, and then come back to go through it with me again. Okay, so then you can check your answers, and if you made any mistakes, you can just correct your mistakes and we can move on. And if at any point you have any questions, you can always either email me or come and see me in school and I will try and go through the question with you. Okay, now starting off with this question here, this question is telling us that O is the center of the circle and they would like us to work out the angle A. Now, since O is the center of the circle, I can clearly see that this line here is the diameter of my circle. And I can use two things. I can say angle at the center is double the angle at the circumference, therefore this is going to be 90 degrees. Or I can also say an angle in a semicircle will give us 90 degrees, therefore this section must be 90 degrees. Okay, now as soon as I write my 90 degrees there, I can see that this is a triangle, and we all know that angles in a triangle add up to 180 degrees. So we're going to form an equation to say that 90 degrees plus 55 degrees plus A degrees will give us 180 degrees. 90 plus 55 is going to give us 145 plus A equals 180. And what we need to do is we need to take 145 away from both sides to find out what A is going to be. And I'm going to write A here. A equals 35. There is usually going to be either a dotted line or a straight line at the bottom of this question where you will need to write down 35 degrees. Okay, now I'm going to leave this example on the left, and I would like you guys to just pause and have a go at this question on the right hand side, and as soon as you finish you can just replay the video and check your answers. Right, so same thing here, we can say two things. Angles at the center is double the angle at the circumference. Since this is a straight line, this is 180 degrees, therefore that's going to be half, that's 90 degrees. Or you can use theorem number one, which is angle in a semicircle will give you a right angle which is 90 degrees. So since that's 90 degrees, and I know that this is a triangle, interior angles of a triangle gives you 180 degrees. So we've got 90 degrees plus 75 degrees plus A will give us 180 degrees. So this is 165 degrees plus A equals 180 degrees. Remember, we need to balance the equation to find out what A is, and we take away 165 from both sides because it was a positive. So A now is going to be 15 degrees. Right, so these two questions are going to be quite straightforward, and mostly when I teach this in the lesson, you guys ask me, oh, is it that easy? It is that easy. Once you know what theorem you're going to be using with circle theorems, these questions are going to be quite straightforward for you. The question is not specifically asking us to state the reason why we're picking this, but when we look at this question, we can see that this is the angles in the same segment from a common chord are equal. So that being said, I'm just going to give you an example here. So it starts and finishes at the same point. So this indicates that there is a common chord. Therefore, these two angles are the same. So this gives us 25 degrees. And same thing here. These two angles, because they are in the same segment from a common chord, that means that if this is 34, B, this B here is going to be 34 degrees as well. Right, we are carrying on with the same theme as the first question we went through. So A, B, and C are points on the circumference of a circle with center O. Work out the size angle X. So we're trying to find out what X is. So we can clearly see that there is a triangle and a semicircle, and you can use angle in a semicircle will give you 90 degrees. Or you can also say angles at the center, which this one is 180 degrees, is double the angles at the circumference. That makes that 90 degrees. Okay. Now, since this is 90 degrees and we have a triangle here, interior angles of a triangle add up to 180 degrees. So we can do 90 plus 55 plus x equals 180. 90 plus 55 is 145 plus x equals 180. Then we can take 145 away from both sides, which will give us 35 degrees. Okay. So using the same theorem, this is the second part of the same question. So if you remember the previous question that we went through, this is the second part of that same question. So this one says A, B, C, and D are points on a circle. AXD and CXB are straight lines. So AXD and CXB are straight lines. So these are straight lines. Okay. AX is equal to BX, AX is equal to BX, which shows us with these two lines here, that just shows that it is an isosceles triangle. Okay, these two lines are equal to each other, therefore this is going to be an isosceles triangle. And as soon as I have that information, I'm just going to quickly write it down because these things are going to help me as I'm trying to complete this question. Now the question is asking us to prove that CB is not a diameter of a circle. So C to B is not a diameter of the circle. So if C to B was to be the diameter of a circle, and I knew that this line was the diameter of a circle, then that would indicate that this angle here, let me just get rid of this bit here, angle CAB is 90 degrees. Okay, and the only way I can actually prove whether or not it is going to be diameter is to find out what this angle is, and if it is not 90 degrees, then that means it is not the diameter. Now, I think this is going to be quite useful for me to just use these two sections here. So we've got 50 degrees, and these two are going to give you 180 degrees. And remember, this is an isosceles triangle. That's what the question says. These two lines are equal. So we can do 180, take away 50 to find out 130. So these two angles are going to add up to 130. That means we need to half it to give us equal angles. So that's 65 and 65. Okay. So this is again angles on the same segment. So if that's 27, this then is 27 degrees because they are angles in the same segment with the common chord. So I'm going to try and figure out if 65 plus 27 is going to give me 90 degrees, and if it doesn't, then it is not a diameter of a circle, and that is me proving that C to B is not going to be the diameter of a circle. So 65 plus 27 is going to give you 92 degrees, so that is 2 above. Therefore, C to B is not a diameter of the circle. Okay. Okay, so next question. Pause this video and try and have a go at this question, because I think everyone who's watching this video is going to be able to do this. Right. This is very obvious that we're going to be using a theorem where the reason is the angle at the center is double the angle at the circumference. So whatever this angle was, this is going to be double that. Therefore, that's going to be 100 degrees. Right, similar type of question as the previous one. Make sure you pause the video and try this question. There are two things that I need to write down in order for you to get 2 marks from it, remember. Okay? Right. The angle we're looking for is going to be AOC, so this bit here. And we can clearly see that this is going to be the angle at the center is double the angle at the circumference. Therefore, this here is 2 times 85 degrees. So we've got 170 degrees. So this question is question B of the previous question where you had to do angles at the center is double the angle at the circumference. This one's asking you to find out the angle PSR, this one here. And since we have 4 points on the circumference, we're going to be using the cyclic quadrilateral rule. So the opposite angles in a cyclic quadrilateral always add to give you 180 degrees. So that means the angle we're trying to figure out and 126 is going to add up to give us 180 degrees. So my rule is going to be, I'm just going to write out my reason. So we have the opposite angles in a cyclic quadrilateral is going to add to give us 180. Therefore, this bit is 180 take away 180 degrees take away 126 degrees, which will give me 54 degrees. Right, so this is question C of the same question. It says W, Y, X and Z are points on the circumference of a circle center O. ZX is a diameter. So this section here is a diameter. Okay, so as soon as I know that that's going to be the diameter, I can clearly see that that's going to be 90 degrees. Okay, so I'm just going to write my 90 degrees there straight away. Then angle YZX is 63 degrees. This bit here is 63 degrees. That's great. Work out the size of angle ZWY. So they would like us to work out the size of angle ZWY. So this is the one that they want us to find out. I'm just going to call it X. So it's quite useful for me now that I wrote this 90 degrees here, because I can clearly see that this X is the same angle as ZXY, which is this bit here, which I can call Y, because they are angles in the same segment with a common chord. So let's show our workings out. We need to do, since it's a triangle, Y, 90 and 63 will add up to 180 degrees. 90 plus 63 plus Y will give you 180 degrees. We're going to add 90 and 63, then take it away from 180 degrees. 153 plus Y equals 180. So what I need to do is I need to take 153 away from both sides to balance the equation. And I'm going to find Y to be 27 degrees. And I'm going to say angles in the same segment from a common chord are equal. Therefore, this bit here is also 27 degrees. Okay. Right, O is the centre of the circle, work out the size of angle A. There's no need for us to give the reason, they're just asking us to just circle the answer. We know that this is angles at the centre is double the angle at the circumference. The centre is A, that's what we're looking for. 65, we want double 65, we can do double 65. 130, pick the answer and move on to the next one. Now this is question B of the same question. So we can clearly see that we've got 1, 2, 3, 4 points touching the circumference, therefore we're going to be using the rule for opposite angles in a cyclic quadrilateral will add up to 180 degrees. So B plus 85 adds to 180, 85 plus B adds to give you 180 degrees. When I take 85 away from both sides, B will be 95 degrees. That's my answer, and I'm going to get 1 mark from it. Right, this is the third part of this question. So we did question A, question B, now we're doing question C, and in total you're going to get 6 marks. It says A, B, C, D are points on the circumference of a circle, centre O. Okay, so this has got something to do with opposite angles of a cyclic quadrilateral. It says angle BCD, angle ABC, angle OBC is equal to angle ODC. Okay. Oh, so it means this bit here is the same angle as this. Work out the size of the angle ADO, marked X on the diagram, and you must show your working, which may be on the diagram. Okay, that's great. So this is a cyclic quadrilateral, first of all. Okay. Now, if this is, by the way, the angle 105 is actually representing the green one here. If this is 105, then that means the total of this section plus this section should give us 180 degrees. So that means this green angle here must be 75 to give us 180, because 180 take away 105 is going to be 75. So I'm going to use the same rule here. Opposite angles on a cyclic quadrilateral will give us 180 degrees. This means if this is 130, this bit here is going to be 50 to give me 180. Okay. Then if I just pick a different color and just highlight it for you guys, you'll be able to see it. Look, this one is the same thing as angles at the center is double the angles at the circumference. And that being said, if that's 50, this is going to be 100 degrees. Okay. Then get a different color. This also is a four-sided shape. And 100 plus 130 plus this little section plus this little section should give us 360 degrees because it's a four-sided shape, and we know that these two red angles here are equal. That's what the question was telling us. So the question said OBC to ODC are the same angle. So I can say that I've got 100, I've got 130, so this is where 100 comes from, this is where the 130 comes from, and then I can find out what these two are. Okay, so 100 plus 130 is going to give you 230. With these two red angles, it should give us 360. So if I do 360, take away 230, that's going to give me 130. And I'm going to divide 130 into these two equal angles here. 130 divided by 2 is going to be 65 degrees. That means this section here is 65. This bit here was 75. and this bit now, which was x, and this is what I wanted to find out, this angle here is now going to be 75 take away 65, and that's 10. So that is going to be 10 degrees. Right, make sure you go through these questions over and over again, and if you don't understand any of them, either email me or try and find me in school, and I will try and go through the questions with you. Have a good weekend, and see you later.